Hello and welcome to this SlimDevOps episode 57 with Stephen again. Hello Stephen, welcome back.
Hey Martin, hello chat.
Hello chat indeed. So welcome back to Yannick. Hello Pete, it's weird to have you on the other end of this. And hello Rich, thanks for coming over and joining us here. I see there's a few more of you. Hey, Ad-user, how you doing there? Welcome. Thanks for coming over as well. So, welcome to the SlimDevOps stream for those of you that are new here. So, Stephen is well. Do you want to describe what you're here doing at Slim, and then introduce what you're going to be showing us today?
Yeah, so I'm a DevRel co-op, so I'm from Northeastern, and I'm a third-year CS student. But I'm going to be here I've been here for about 3. I just passed my halfway point for this co-op, I think. So I'll be working at least through December on all kinds of projects, really. My main focus is demo container, like slimming processes. So I've spent a lot of time, writing tutorials on, using Docker Slim and our Slim SaaS to optimize and, clean out vulnerabilities from like different popular containers.
Indeed, and I think what you've got lined up today is some show and tell on 3 different projects that you've been working on.
Yep. So first I have, I don't know what order we're going to go in. I have one that's like it's a whole stack of four. It's a 4 container stack based off of a Golang API, a React front end, and a Mongo back end, and then a little sidecar container. And that just last week, I think I finished like slimming that entire stack and had tons of cool results from that we could look at. And then we kind of have a project in the medium stage where I'm kind of in the troubleshooting process on a like basic little Rust web server that we're trying to get slimmed.
Okay.
And then third, I have a container that's I haven't really done full investigations into, but it's a 9 gigabyte container based off of the open source Crayon Dolly Mini project on GitHub.
Right.
And it's a 8.95 gigabytes, and I run some scans, lots of vulnerabilities, and I thought it would be fun to investigate, look at how it ended up like that.
Okay, so take a first look at that one to try and figure out how we tackle that in terms of making it not 9 gigabytes. If indeed it's possible. I imagine it might be the training data that's in there, but we'll figure that out. So also, hello to the learner. Welcome to the stream. Yes, we're doing a couple of new things here as well. We're actually, hopefully, we're streaming on YouTube as well. So we're expanding where we're streaming to, and for the first time, we've overlaid the chat on screen. We're going to give this a go, and over the coming weeks, we're just going to ramp up sort of some of the capabilities we have here for interacting with you, the audience, when we do these streams. So, Stephen, where do you want to start with all of that? Which do you want to take a look at first?
I think maybe we start with the 9 gigabyte container.
Oh, really? You want to go straight in with that?
Yeah, well, it should be the starter end. I don't think that's a middle one.
Right. Yeah. Okay, then. Do you need to share your screen or anything like that?
Oh, yeah, sure. I can show you. I'll just do the whole thing.
Hello, Lindsay, and hello, John. It's been a while. How are you? Thanks for stopping by. And Corazin as well. Hello there. How are you?
Got my screen, Martin?
Yes, I think it's here. There we go.
Let's jump away. I don't want to put you in that infinite loop. So I guess we'll start. This is the open source repository right here. It's called Dolly Mini, not affiliated with the OpenAI Dolly project, though. Little disclaimer. This is Crayon with an AI, that project. So this is the app structure, or the project structure. A quick walkthrough. You'll see there's a Docker folder for I have this locally too, but we can go to the Docker file. It's based off of the NVIDIA CUDA.
Okay.
This base image, run some Python installs, and then there's in 2 repositories. This one that it's contained in, and a second one for loading, I think, the image generation models. And then you sort of run it off a Jupyter notebook.
Right.
Which we can actually see it in this folder, I think. Yeah, the tools, inference, this, yes. Let's see if, okay, let's preview. So in addition to this container being 9 gigabytes, there's actually some more hidden size to that, where once you pull the 9 gigabyte image, which is going to vary a lot the time based off your internet speed.
Yep.
And then you get it running, nearly instantly, which is nice. But then you see installation and setup, where you have to do probably another 9 gigabytes of installs.
Right. Okay.
From this walkthrough.
So once you've got the container and the container's running, you then need to step inside it and do a bunch more stuff.
Yes.
Okay.
You run some pip installs in the notebook. I think the ones that really end up eating the time, I want to say, are maybe this load models one. yep, from all this, because this is going to refer over to the weights and biases website and load in like a 5 GB model.
So these are additional steps that you need to run in your notebook, which go and pull down training models and things of that nature.
Yeah, which is less than
Wow.
ideal for, you kind of you kind of want when you're building and running your container, you
That it's
expect
just
everything
ready.
to be set up.
Yeah.
Yeah. Now this is we've talked about how this is something we see a lot in the more like data science related containers, where they have some different goals, more that just like they can pass this to other data scientists and they can use it to walk through. But there is, I think, a lot of room for quality of life improvements. Even if this Jupyter notebook isn't going to be hosted online for like a ton of traffic.
Yeah.
So just continuing through, I think there's somewhere where that same model gets replicated and you have to sit through another 5 GB of loading, and then you can finally modify the prompts down here.
Okay.
Like sunset over the lake in the mountains. If anybody's familiar with, if anybody's experimented with text to image models before, you can have a lot of fun with these. And then the generated images is going to be entirely, the speed of that is going to be entirely based on what kind of GPU you're using. I've run this before on like literally a Pixelbook like processor CPU.
Right.
And that was about like 6 minutes per image.
That's not too bad considering.
Yeah. Although actually, now that I think about it, on the Chromebook, I changed one of the lines in here. Where is it? Yeah. If you see right here, if the notebook crashes, you can use the smaller version. So those images were 6.5 minutes, somewhere around, and much lower quality than this larger model. The larger model, I think I'm able to get like just under 30 seconds per image using a 3080.
Right.
Yeah.
Yeah, because this is a reduced complexity AI image generation tool. There, some of the newer diffusion techniques take far longer than that, even on powerful hardware. But the quality of the images that you can create is significantly higher fidelity. So I just want to acknowledge, hello Felipe, welcome back, thanks for joining us. Yeah. So here we are. Stephen's elected to dive right into hard mode and take a look at this 9 GB DALL-E container as our first thing we're going to look at. And I see that Pete has already been talking to me today about our Halloween special we'll be doing. That'll be on the 31st of October, of course. And he's suggesting that a prompt should be stream hosts dressed as evil characters, because he wants some ideas for what we could be doing. So, right then. With that in mind, so what do you want to do? Have you actually got all of this stuff on your machine? You've pulled down the initial container and initialized it effectively through those manual steps.
Yes, I have the which tab is this? Yep, so I have the Docker file built, 9 GB. I don't think it's a great idea to run it right now, because then we're just going to bump into those large installs, which we don't want to sit through. But I did already run scans in the Slim SaaS that we can look at.
Yeah.
So we can start seeing what's like making up this container. Right. Yeah. So this is the overview of it. There it goes. It rounds up 9.0 GB uncompressed. See all kinds of shells, files, and then the vulnerability scan. We got like what's around. Oh yeah, we just added this.
Given its size, that's not bad. I've seen far worse on far smaller containers.
Yeah, what was it? Earlier today, I ran a gripe on, it was some node-based container, and it was 20th or 30th at the size of this. It was like 300 megabytes, and oh god, it was I think Ripe reported like 2,000 vulnerabilities. It was old. Um,
Yeah.
That's like one of the largest per megabyte I've seen. So this isn't crazy. This is based off I have the scan of the base container as well.
Okay.
Which
you hit on an interesting point there. You were saying vulnerabilities per megabyte. I kind of like that as a way to sort of quantify how bad it can be. I think the worst that I've seen that's like an official container is the official Python latest container. That's nearly 2,000 vulnerabilities in that container, which is a bit it's a bit hairy. And I see, so Felipe Cruz is with us, who works at Docker, and he has an interesting observation, which is, once installed, can those ML models be stored in a Docker volume? Maybe this is something we could think about, like, how could this container image be improved? What we learn from this, how can we contribute back to make it better for the next person?
Right, that's actually exactly what I was, the kind of idea I was referring to when I was saying, even if this is a data science container that doesn't need to be, that isn't going to be hosted and it's going to be for, like self-hosted personal use, like a Docker volume like that would be like a huge quality of life improvement for somebody that's like repeatedly running these containers. And also, I was thinking at some point in the next month, I'd look into, using volumes, if there would be an easier way to just rather than build a container around a single model, just load up different volumes into the same container, so you can pull whatever text to image model you want off of weights and biases, not just the one in this Jupyter notebook.
Right. Yeah, that's a good idea. Yeah. And there was some additional steps there to actually install some of the Jupyter notebook technologies, the components. There's no real reason why that couldn't be. It's just this for all these pip installs here. There's no reason why we couldn't look at either pre-installing those in the container, or pre-installing them into a volume.
Yeah. Now I'm actually curious, because I've never written a Docker file for a Jupyter notebook app, nor have I tried to Slim one. Is there not some kind of redundancy here where we have the pip install here in the notebook, and then we also do see the pip install over in the Docker file? Yes. So.
Oh yeah. So yes, I see both of them there. In fact.
So I'm curious, with this line, is the pip install in the inference folder, is it even necessary? I'm not entirely sure how the notebook would work.
It looks like those dependencies will have been installed into the container already.
Right. Yeah. So that's
Yeah, those two were definitely referenced, weren't they?
Yeah. I wonder if this will if the dependency is already installed and then you go and execute this. I suppose it should see that and install instantly anyway.
Yeah, there's no upgrade flag there, is there?
Yeah. So I imagine, unless we're running this notebook in a non Docker environment, this wouldn't really be necessary.
Yeah. Okay, interesting. So going back to the analysis there, so actually the vulnerability count's pretty decent at this point. And I see Corazon is pointed out that the Node who was casting aspersions about Node. I think I said Python. I'm pretty sure I said Python this time.
I might have misspoke actually, because I might be misremembering, because I did scans on some Node containers and some Python containers this morning. So I might have mixed up the vulnerability count. The Python latest might be the guilty one. Yeah,
it's definitely bad, that one. I use that in my 5 best security practices, because it's such a such a terrible starting point. This is the
Although,
Python latest using Debian as the base distro.
yeah.
Their Alpine images are good. And the other thing I just wanted to point out here, because this is a change since the last time we used
Hmm.
the vulnerability scanner on stream, we've had a point where we showed this vulnerability scanner just with Gripe, and then we had it, I think may have been last week, just with Trivy, and now you can see here that we have both enabled, and so both engines are used to do the vulnerability analysis, and then the results are normalized, so the duplicates from both get filtered down, so you get the benefit of using multiple scanning engines when you're checking the security of your container.
This feature is also pretty new as well. I don't know if it's appeared on stream yet, the vulnerabilities versus occurrences. So now we've got some further insight to repeated vulnerabilities, I guess.
Right.
Yeah. Maybe we'll also get to later if we circle around to my Mongo project. I was pretty impressed by the smallest container on that stack. Because originally I didn't plan on slimming it. I saw it was 5 megabytes and was like, I'll focus on the bigger ones. The Mongo is about 500 megabytes, I think. But then I did a quick scan on the little 5 megabyte container, and it had, I think, close to 100 vulnerabilities.
Wow.
So yeah, that was a pretty bad vulnerability per megabyte if we're using that metric. Yeah.
I will definitely have to take a look at that, because you've piqued my interest, because I had a little look at that sort of suite of containers when you were working on it, and I remember I thought that container was just there to provide configuration, basically.
Yeah, I was nearing the end of the project, and I was like, I should probably just check on that. I was thinking, it's feeding environmental variables to the other containers,
Right.
can't imagine there's much trouble there. And then I was like, whoa, that's a lot of vulnerabilities for that
Yeah.
little bit of functionality.
Yeah, it was an interesting pattern, actually. Also, I'd just like to welcome back our podcast, Eric. Hello, welcome back, and also Takov. Hello, you. Thanks for stopping by. Yeah, when we were looking at those containers, I thought it was interesting because they're effectively using this sidecar container to implement sort of a singleton pattern. It's basically exposing a bunch of environment variables to all of the containers to provide, a common reference for the Mongo database authentication and port configuration and things of that nature, which is interesting. I've been battling with singletons just recently. I say battling with them. I have read. It seems to be that developers are trying to persuade other developers not to use singletons as a pattern, and I've been doing a little bit of game development learning on the side, and the temptation to use singletons is extremely high, and I've been trying to not do it, and I've been finding it tricky. Right then.
Yeah. So I guess we can move on to seeing what's actually inside.
Let's have a look.
The File Explorer here. So we've got 7, 8, 13 layers here. Empty.
Okay.
13. They seem to be pretty spread out in additions. What are the bigger ones?
There's a 2 gigabyte layer, and there's a 2.8 gigabyte. Oh, and a 2.9. My gosh. Okay.
Yeah. Oops.
These will be the various when there are a bunch of like Git clones or something like that. Pip install or whatever.
Yeah, it looks like it's mostly belonging to this folder.
Oh, right. That's the CUDA libraries by the looks of it. So, because that's right. So it uses a base image, which is an Ubuntu image that NVIDIA published, which is Ubuntu plus the CUDA stuff. So it's quite possible that the first layers are from that.
Hmm. Yeah, I think that container is quite large. Also, do we want to? We can run an X-ray from the Slim portal.
Yeah.
On that.
And the other thing I'm thinking is, it is possible there's a project. It used to be called something like the NVIDIA Container Runtime or something like that. And the way that works is, instead of bundling the NVIDIA libraries, the user space for the NVIDIA stuff, CUDA effectively, inside the container, it automatically creates the necessary bind mounts, like volumes essentially, to the user space on the host, so that you don't need to ship all of that stuff inside the container, which is good because it ensures you maintain ABI compatibility between the running kernel on the host and the NVIDIA modules that are loaded by that kernel and what the container's running. Otherwise you can get an incompatible mixture of user space and kernel modules.
Interesting.
But could be a way to bring the size of the container down.
Okay, this base container, the CUDA one, 7.7 gigabytes in the root.
Nice.
So that's going to answer the question of where most of our stuff is coming from.
Right. So yeah, I think that's going to require, like, we could try and re-engineer this container by using a different base image as the starting point. Like, actually take an Ubuntu base image and use some of these container runtime tools.
Now, what do you think? Because I've never run like Docker Slim against like a Jupyter notebook before, or on a NVIDIA image like this. What do you think? Do you think Docker Slim would be able to like clean some of this up?
I think it will be, by default, it will be way too aggressive in what it removes, because for the observe to really be accurate, we're going to actually have to get the notebook loaded up and probably generating an image whilst Docker Slim is running to ensure we capture all of that notebook requirement, and also all of the underlying CUDA libraries that the app actually is using under the hood. So I think we would probably have to initially run Docker Slim like manually, and step through it to actually see what we can capture before we go too far. Yeah,
so that might be an off-stream task if given that just getting through the manual interaction with the container is going to take a lot of installing time and a lot of GPU time.
So, but we've learned some things already. We've learned that maybe the very base of the container could be optimized. We've also learned that actually the security profile of this container is pretty decent when you consider just how much stuff is in it.
Looks like
and we've got some ideas about how else we could better optimize the image, at least optimize the use of it, by using multiple volumes with different data sets in them, for example. Those poor data scientists indeed.
It looks like also from the base container to the whole project, only 9 new vulnerabilities introduced.
Okay, that's an interesting. That's interesting too. So that's fair as well, because if you think about it, it's mostly Python dependencies installed via pip, and it looks like they're pulling it straight from Git master, so it should be up to. I mean, there's some best practice we could apply here, isn't there, for versioning and what have you. So there's lots of discussion here. I think we just need to let's just switch our view here, and we'll look at some of the questions that have come up, because there's been a few. So
I'll stop sharing.
Takov says, I had a similar experience with the pterodactyl core Docker image. It had a vulnerability from 2017 because of an old Oracle Java version. Yeah, okay. And Takov also helpfully suggests we could create a GitHub or GitLab worker on hardware with a GPU, and then you'd be able to run the actions without manually testing. But I think we want to manually control Docker Slim in order that we can actually see, what it's trying to do. But yes, once we figure out how to automate it, we could run that in CI/CD, and I think that's something we're going to dive into in more detail in the future as well, is actually doing this stuff in an automated pipeline.
Yeah, you can automate the with Docker Slim. You can include an execution file, which typically when I use an execution file for Docker Slim, like if I'm monitoring a container without an automatic probe, I will shell into the container, do whatever with it, keep a log of every command I use, and then I just save that in the exec file, and if I ever want to replicate the slimming process, I can just pass it that instead of doing it manually.
Yeah, indeed. So Eric points out that yes, the struggle is real for data scientists. I think, Eric, the upside is don't you, because Eric is a data scientist, isn't the upside that you all get Threadripper workstations with a terabyte of memory of memory and very fast storage arrays? That's how it works, isn't it? That's I thought that was the benefit. And then Corazin also makes an interesting observation, which is, do you think some of these vulnerabilities exist because people think, oh, it's in a container, so it's safe? I think that's probably a more optimistic take on what's actually happening. So this is purely anecdotal, but in our experience, a lot of the people that are producing container images are just happy if they get a container image that works. There aren't many people outside of DevSecOps that are making containers that are really thinking through the security profile of their containers. I think a lot of people that are producing containers just want one that works. And as we've seen, without caring about the size or necessarily, its best practice composition and security profile. So it would be nice to think that people are thinking it's in a container, so it's safe. We know that's not the case, of course. One of the things I've been talking about in the 5 best security practices is, if you've got all of this stuff in a container, this one wasn't too bad, right? It was 100 something vulnerabilities, which is not awful. But if you've got vulnerabilities in your container, it's more than just the vulnerabilities. It could be the vulnerability in your application that you don't know about. And if somebody is able to compromise the app and then step into the container as a result, so some kind of buffer overflow, if you're running, and we see this a lot, I don't know if this container was running in the root context, I think it was. But if you compromise it, you're now root inside the container, and we see an increasing trend of production containers that are published publicly by significant organizations that include test, QA, infrastructure tooling in the production containers. So if you're a would-be attacker and you've landed inside this well-instrumented container and you're root, you can use those tools that are in the container to disrupt the infrastructure of the adjacent containers and disrupt the services. So it's not just so much about the security of the application, it's what exposure does that container have to the rest of your infrastructure. So one of the things that slimming can do, even before we talk about removing unnecessary software components, is all of those shells that we don't need will get yanked out. Things like netcat that don't really need to be there, and wget and curl will also get yanked out. Unused interpreters get yanked out. So if you land inside this container now, hopefully it's more of a sort of a barren wasteland with nothing useful in it that can then be used to disrupt the infrastructure. So you know, security is a real interesting point.
There's definitely a developer perspective where people will say like, oh, I'm not exposing this dev tooling to the end user, so what do I care if there's 50 vulnerabilities in it? Then as soon as the vulnerability that is exposed to the end user is exploited, all of those other ones come on the table.
Yeah. So Big Pod says once you know what Docker Slim needs, you can automate it. So yeah, that's sort of the idea, is figure out what the steps are by manually poking at it and then building an automated profile from that. And John Euler helpfully suggests that don't the DevOps guys all get Raspberry Pi 4s, the 4 gig model? Yeah. No, they're not bad, to be fair. I quite like tinker. I've got one here, a little Raspberry Pi workstation. Admittedly, I did blow out for the 8 gig model. Right, okay. So what should we look at next then?
Why don't we check out that little 5 megabyte container we were talking about?
Oh yeah, okay.
With kind of thick vulnerabilities. Yep. I'll screen share again.
Yeah, whilst you're doing that, I should just read out another note here from Corazin. So he says, as someone doing the development part of the development cycle, he thinks my anecdotal assessment is correct. Well, that's good to hear. Yeah, you speak to people, you get a feel for how it is. And Corazin goes on to say, I don't know how many times I've said, don't you think we should upgrade that container from Ubuntu 18.04, and heard that is the only one supported on the deployment platform side because developers don't want to deal with deployment. Yeah, it's true. And in fact, Pete and I did a stream when the 22.04 release, the Ubuntu 22.04 release came out, and we were doing a simulation of that whole I've got an app, can I migrate to the new version of Ubuntu? And we used the Slim.AI tooling to sort of do the discovery and analysis of what was in the container, build a new container, and demonstrate that the new container built with 22.04 was functionally equivalent, but there were differences. The new container was slightly bigger, but we were able to dig into why that container based on 22.04, we were able to identify precisely why it was bigger. And the reason was that the dependencies for the Python interpreter in the newer versions of Debian and Ubuntu include the Sphinx documentation management engine, and that manipulates graphics, so that pulls in a whole bunch of graphics libraries by default. And of course, once we minimize and optimize these images, we get back to a small image that we had before we did the uplift of the new Ubuntu version. But yeah, I used to work at Canonical. I don't know if you're aware of that, and I'm not going to say who it is, but one of the reasons why ESM exists, which is this extended support maintenance or security maintenance, is because there was a significant customer who was running Ubuntu 12.04 and could not upgrade, but they were prepared to pay through the nose to continue to get security updates for it, which is why Ubuntu 12.04 was on the ESM program for such a long time. I think it still is, but there you go. Yeah, people don't like to move infrastructure to new versions of stuff. It's shocking.
I like to think when a developer gets that container to work for the first time and is passing their test, there's a little devil on their shoulder telling them that it's ready for production. Just do it.
Yeah, ship it.
Don't scan. You don't have to slim or scan or harden.
Yeah.
It's ready. Test coverage.
Now, for those of you in the US that are working with the DoD now have updated guidelines which says you can't provide a container to the DoD that contains any known vulnerabilities, which is a very high bar to clear. So fortunately, we can help with that because that's what we do. But yeah, that's tough. Right then. So shall I switch over to the screen share again? Yeah,
sure. Yeah, I didn't know about that DoD requirement. I've worked on did a little bit of work on a DoD container before, and I can imagine that old team's panicking.
Right.
All right, which tab was it? This one. Okay. I think I have to re-pull it down, but that'll be really quick. This is the compose file for the full stack.
Okay, so this is a whole, basically a Mongo stack expressed in a Docker compose file. Is that right?
So we have the front end, which is going to be, I think it gets built at, and it's not getting pulled yet. So there's a compose for there, and the client, there's a Docker file on the client side. Node 14, Alpine. But anyway, back to the compose. And then this was the front end sidecar environmental gen.
Right.
Oh no, that's running off of my, this shouldn't be running off my Slim one. Believe, where's the name of the original? That should be in my.
So just being asked if you can zoom in a little bit on your VS Code. Thank you.
So much. Is that okay?
One more, I think. There we go. That's
right. Good thing I recorded like the full process. What's the name of the pull? Yep, it's this one. Okay, cool. Those. So let's see. Right, how big was this? Here we go. All the way at the bottom, 5.58 megabytes.
Right.
Okay, let's see if my memory is serving me right, that this had a decent amount for its size.
Right.
Actually, quicker if I just...
Corazin. Okay. So.
There we go. 71.
I didn't realize that. If you're looking for another podcast to listen to, Linux Downtime, I do that with Joe Ressington and Hayden Barnes and Gary. So yeah, head over to linuxdowntime.com.
Yeah. Right. So we hit 71 vulnerabilities with Gripe. What if we look 1, 2, 3, 4, 5 critical? And I think our 9 gigabyte image had 6 critical vulnerabilities.
Right.
Yeah, so that's an interesting result for this.
And that's is that an Alpine based container? Oh, it is an Alpine based container, and it's an ancient container as well, because this container was built and it only effectively has the SSL libraries and certificate bundles and a bunch of environment variables, but I don't think it's been refreshed for years. So I imagine that like the bits that are in that container just are old and stale.
Exploring it. This is a good use of the desktop extension. Can we see the overview on this?
Yeah, I mean it's really tiny.
Oh, right. Can I zoom?
Alpine 3.12. So 3.16 is the current version, or 3.17, I think.
Yeah.
Just check that.
I don't know if I can zoom the Docker desktop. Yeah. Open this in browser instead, I guess. So what kind of investigations do you think we should do into this, Martin?
Well, I mean, what's interesting there is we could slim it, and I think some of those vulnerabilities will go away, because I'm pretty sure that APK tools won't be required by the running application. But I see that BusyBox is one of the vulnerable components, and that is the whole point of Alpine. So there's going to be a bunch of stuff we simply can't mop up, because BusyBox isn't going to get removed. There will certainly be some. Well, actually,
so let's see. I do have a
Yeah, actually minimize it. Let's see how much it gets rid of. It'll be interesting if it leaves BusyBox
actually
or not.
Just realized I don't have to run that because I've done it before.
Aha.
There's a Slim one on my Docker hub. I can just pull down. See what the scans turned up for that. It ends up at 1.66 megabytes.
Okay.
So that's like a quarter of what it was. Yeah, that's pretty good.
Yeah, all savings are good savings.
Yeah. So let's run gripe on it. I found gripe in here is sometimes not as cooperative on the Slim images. Yep, so it's not even identifying the packages to gripe.
Yeah, and that's because in the slimming process, some of the package metadata can be removed, which is what gripe requires in order to, figure out what's in the installed system.
One thing we could do is we could pop open the Slim portal and compare the Slim to the original. Do you want to do that?
Yeah, well, that would be good. Yes, that would be good. A file comparison at least would be an interesting process.
Let's drop out of here. You can all see my cool. Okay, we only have. We'll compare. We should be able to just. The other one is on Docker Hub. We should be able to. What was
just
the name
search
of
for it? Yeah.
Yeah. This one. This is the.
I've got another idea. Do you have Docker Desktop installed?
Yeah, I just had it open a second ago. Remember, it was,
so
it was a little hard to see.
Oh, okay, because we can't zoom this. Yeah.
Yeah. Oh, so I figured the browser would be better.
Yeah.
Well, that's fine. Oh, I have that on my Docker up already. Cool. Just use mine. Select version. Latest. Compare.
Okay, so you're comparing your small one to the large. I think you probably want to, flip those around. So the big one on the left.
I start at the right side 0% of the time. It's like putting in a USB. Yeah. Okay, cool.
Okay, so now what we should be seeing is everything that was removed, and okay, so there's a whole bunch of like distro stuff in Etsy that just gets tossed out. So if we take a look down that list there, I'm interested to see what's in user bin and bin. Let's just load. Look at all that stuff that got thrown away. I wonder if busy. So actually, if you go to the top and search for BusyBox in there. So what the quickest way I find to take a look is if you change it to flat. That's it. Yeah, and then just search for BusyBox. It got removed. Okay. So there we go. So we know that is gone. Have you still got the tab open with the vulnerability report in it?
I've got the well, actually, we could do vuln diff, but yeah. So I mean, it's not picking up on the.
Yeah, no, that's fine. One. So if you go back to your gripe output,
that's interesting. It's saying down 29. Our gripe scans at 70.
Yeah.
Interesting. It's okay. It still has the five criticals.
Right.
4.
Right, which are zlib. Okay, that's fair enough. That's probably something using that. But if you go and look at your gripe output from the command line that you ran, so.
Oh, this is the wrong tab. It was. No, it was this one. Cool. Yeah.
From the original. There we go. So let's find something here. So APK tools, for example, we could search for just APK star, and see if there's anything left behind that might be that. This is one way you can go and poke around. So there we go. We've got one which is, and it was removed. So yeah, it's fine.
Cool. Yeah. I guess we could. I mean, there are only a handful of criticals.
Yeah. What I could do is, like that libcrypto, for example. I mean, that will probably still be on there because I'm pretty sure part of the configuration was some SSL stuff. But if you just do libcrypto and drop the 1.1, that's it. There we go. You can see they've been removed as well. So this is like a useful way of you have this report that says these were the vulnerable things. You can actually qualify whether or not they're in the container or not. Yeah. Same process. That's it. You got it. And that's not in there either. Okay. Well, I'm surprised. I would have expected that to be in there.
Yeah, I'm actually curious, because the command I used to slim this, which doesn't actually end up breaking the this slim image works for the stack and feeds the environmental variables to the other. So I know it works, but if you look at the slim command I used, it doesn't actually really do anything with the container. It basically just starts it up and then gosh, I keep clicking the wrong. Here we go. Recorded all the slim commands I used, right? Full setup. You can see I basically just I start up the front end and I suppose Docker Slim, if you look at the compose file.
Yeah.
Actually, it doesn't have any dependencies tagged, so it won't even start up these other services, will it?
No. So
yeah, just starting up itself with the probe disabled.
Yeah.
No special tags. It still manages to include everything it needs. So I suppose, I mean, we looked into this a while ago. It was mostly just a bunch of shell scripts, if I remember, in here.
Yeah.
Maybe a little bit of JS.
So I think there's a couple of interesting comments from Big Pod. Hello.
Yeah.
Also, hello to Plank on YouTube. Thanks for stopping by. Big Pod says he could have a field day explaining why this doesn't work for scanning slimmed images and why you might get false negatives, because I know this was something that you were tasked with researching and figuring out all of the edge cases and how this might work. Yeah.
I'm told the engineering team is, or at least the vulnerability scanning team is spending a lot of time on this right now.
Right. Yeah. It's that's a tough nut to crack, but it will be extremely valuable. You can work around this to some extent, like if you're using things like pip to install some dependencies or npm to install some dependencies, you can keep the package caches around for the things that you install via those language ecosystems, and then at least you can get security scanning with accurate results for the stuff that you pulled in through, the language platforms. But if you're using, Debian or Ubuntu and apt, or if on Alpine APK or RPM or Yum or whatever on the RHEL style releases, you effectively have to manipulate those package databases correctly to say, well, I'm removing these libraries, therefore these package indexes need updating. You can't just keep them all around, because then it tells you all of the stuff is still installed, even though you've removed the components from the actual file system. So it is a tough problem to crack, that one. Yeah, exactly. Yeah, and same with some languages as well. But yeah, like I say, if you want to keep those package caches around for your language ecosystem stuff, you can do that with a reasonable amount of accuracy. So you slimmed each of these containers discreetly. You didn't. Oh no, here's one. So up the top here, you've got a slim build pointing at the Docker Compose file directly.
Yeah. Yeah. So actually, all of them do.
Oh yeah, they do.
This is just how I chose to like target the builds.
Yeah.
I suppose I want to say I mean, any of them I could have pulled and just did Docker Slim build and targeted that container. I don't think there's a difference between targeting a compose file and then targeting just the service, aside from some of these services are like if we see the API is like dependent on the DB. So because we're targeting the compose file and not just starting up the API itself, it was easier to identify everything for Docker Slim.
Right.
And you see I'm targeting the dev one. The difference here is just I exclude volumes because in the Docker Compose dev, because Docker Slim does not like that. And is there any other big differences? I might actually add I didn't actually end up doing that on my final result. I experimented with so this DB slimming process took a long time, a lot of investigations, and part of that I was curious if adding in the other services as dependencies would improve the final container. What we can see, what ultimately ended up happening with this database to get it working was in my setup.sh. I needed an exec file with some commands. I needed to include the entry point, and otherwise, I think that was it. If we look at the Slim commands, I needed some ownership on some files that were created in the container, and I needed to shell in, and I guess one of the scripts needed ls, so I rather than I guess that could have also been included through an include path, but it was easier just to execute it.
I like that idea.
Yeah, I was like, 'cause this is the process I said earlier, where you know, you know, once you find out what Docker Slim needs, you can automate it easily. And when I was running around in the container, interacting with the app after shelling in, I was like, okay, these four, and it works.
Yeah.
And that was able to the base Bitnami image I was using was pretty large. It was and the resulting one was large as well, but I mean, it was about half the size, I think, afterwards. If I look at my result, little notes.
Oh right, so here's the size reductions. Okay, so
yeah, 497 megabytes to 273, so about half the size.
Yeah.
I was surprised. These were relatively slim. Like the stack was definitely not, the rest of the stack was not overburdened with dev tooling, but I was still able to get some pretty significant minification factors, like the front end 38 down to 6, sidecar 5 to 1.5.
Yeah.
Go. Yeah.
Yeah, that's some decent savings.
Yeah,
and again,
sure.
So one of the other use cases that we're seeing more and more is deploying to serverless and lambdas and what have you. And some of the providers have some constraints for deploying into those in terms of the size of the container. So slimming can help you get the operational size of the container down, so you can deploy into a lower tier or the lowest tier, or in some case free serverless options, which is obviously attractive. So I don't think we're going to get that 9 gigabyte AI container into serverless anytime soon. No, I think that's going to be a challenge. Okay, so
I can dream.
yeah. So what was the other project that you've been looking at?
All right. The last, the third one, the Rust one. I guess BigPod was helping me with this the other day, and I guess Peter in chat has seen it also. Right, here we go. So yep, this is one of the starter kits we're putting out, which will be on the website soon, as soon as I get it working.
So let's just clarify, what's a starter kit?
Starter kit is so they're going to be available on our website very soon. They're already available on our Slim containers GitHub. I can pop one open real quick because quite a few are done. Forgive the typo on my bookmark up here. So yep, starter kits, so we can see. This the node's a good one to look at. So let me go back. So this is our Slim containers repo. You can go. We have examples and we have starter kits. I'll explain starter kits for now. So we see we have examples of Go, Node, Python, and others will be pushed very soon. Some are actually in the wrong folder and are going to be moved over. But if we look at the Node, so we have two starter kits for Node right now. One is a Hello World, one is a Real World. The Hello World is just, look, here's a basic Node app. Posts, uses a web framework, posts Hello World, and then here's the Docker file, and then here's kind of the steps that you go through to slim it using the Slim SaaS, and here's the kind of results you're gonna expect to get on a Node container. And the idea here is, you're a Node developer and you've just heard about Slim.AI, and you're like, how can this help me? What kind of process? How might the process be different for Node containers? Is there anything important I need to know? And you just go over here and you see, oh, okay, this is kind of results. This is the process.
Yeah, I mean, that's quite the headline grabber, isn't it? That was 900 and change megabytes down to under 90,
87.
so 10x, nearly 11 times reduction. That's not bad, is it? Really?
Yeah. Yep. So. And it was the Node ones, I've found pretty much every time I've worked with whether Docker Slim or the SaaS with Node, I haven't really run into any issues. I suppose some of them, like this Rust one, might have some extra steps in it, which could be helpful to people. Yeah, so moving over.
You've explained that the starter kits are going up on the website, so if you can choose your language ecosystem and you can get some actual examples that orientate you around that, and what you've got here is what will be the Rust starter kit. Is that right?
Right.
Okay.
Yep. So I started this process. I went to the Learn Rust, and I said, an article that was, I think I have it open right now, that was building a single-threaded web server. So this isn't like this doesn't have instructions for making it like cloud native, but here's how using built-in Rust packages you can make a web server. So I put this together, and then I wasn't even running in a container. I ran it locally, and it failed. They have a mistake in here, which where is it in the code? It's where they call unwrap twice. This line of code right here, when it's handling the connection. Your first HTTP request will succeed, and then it goes to read for more, hits an empty request, and then tries to call a function on nothing and crashes your program. And then if you wrapped this in a container, it would crash your container too.
Nice.
So luckily I found somebody with better code, I hope, that does post and run successfully. And I made some changes into it right here, so it would work in a container. And this I can just run. I have the container on right now. I hope I didn't purge it or prune it. Where is it? Yep, Rust Hello World. Right, so this is 1.4 gigabytes. I think Peter said he's spoken to Rust people, and they just say, oh yeah, we like throw all the dev tooling into our container, and that's why.
Yeah.
But see, we could just do Docker.
So
run.
Pete's also in chat, and he's saying, it feels like Rust isn't the place where it has something as easy as Flask yet. But I like this use case because often Rust is being used for low-level, highly efficient sort of concurrent service backends and things like that.
Yeah.
So actually choosing a web server as like your example, I think is gonna tick a lot of boxes in terms of relevance for people from that community.
And I think did I modify this? I think who will tell you? Big Pod, he's done a REST example before. I think he did find some kind of web framework that he was able to get slimmed down. Well, it's just not running. That's curious. That is the port I use, right? 178. Can I curl localhost? Of course, this is gonna start failing now that I'm live. Wait, is that did I tag? Rust hello world latest. Rust hello world. Okay, that's curious that this version isn't posting right now. But anyway, when this container is working like it's supposed to, like it was last time I built it, you know, it just posts these this HTML, hello-rust, and 404 if you make a request anywhere else. And the problem we were coming into here is something that I've hit also on. Oh, I don't have the Java code here. I've seen this twice now where I'm able to get a working basic web server, and then get sort of timeouts when I try to slim it and monitor it.
Right.
Here, let me stop screen sharing for a second so I can hop over and find some code I sent in my Discord. Send it to Big Pod. Right. Yeah. Any Rust experts in Twitch chat that can debug for me? Get them to work for us.
Well, Pete's my choice.
Yeah. That is really curious that it
the container's running, I assume.
The container's running. It's not making the requests are timing out, which was my problem on the Slim container, but not the original one before. And I didn't think I changed anything. Let me see if. And oh, wait a second, it's fine.
Okay.
Oh, did it? Oh, when I stopped screen sharing, it just froze on you.
Oh, I see. Have I not got an accurate screen share? Okay.
Oh yeah. Hold on. I'm gonna restart sharing anyway
Okay.
right now. Let's see.
I'll
Yeah.
just... Here we
That's
go.
why it looked frozen. Oh, there you go. Little loop. Okay. I don't know why those took a second to load, but hello from Rust. There it is.
Okay. So it is working.
Hi from
Cool.
Rust. Yeah. But then we go to Slim. Let's kill our this whole thing. So we do well, first we'll free up the reports. Go. So we do a little build on the Rust hello world latest.
Okay.
And we'll show our. Oh, I added in some comments, so or some logs, so we can see what's.
Oh, I see. So whilst it's actually running, you're able to see that in the Slim process.
Yep, that was some advice Big Pod gave me. Yeah, let's see what happens here. Wouldn't it be great if it magically worked this time? We hit the probe. Yeah, usually. There we go. First command get. Yeah, usually when you sit here waiting for 5 seconds, you should start getting nervous that the get's gonna fail.
Yeah.
Let's see. I think it gives it like 8 seconds to try. It's gonna come up with an error in a second. Meanwhile, why don't I, yeah, we'll try again. Status error. At the same time, I'm not sure if I've actually checked out the vulnerabilities on this 1.4 gigabyte Rust one. What do I name it again? We can kill this. That's node. Let's go. I notice I've been working on starter kits because I have like 20 different Hello World containers.
Yeah.
Here we go. Oh, that's what Gripe says about this. This was a high count one. Maybe it's competing with the Python.
Oh, right. Okay. So why are you disabling the probe this time?
Oh, shoot. I hate when Gripe does that. It just filled up the whole console with me. I'll answer that real quick. It's not txt. We'll output the vulnerability report to a file so it doesn't fill out my console.
Right.
Why did I turn off the HTTP probe? Okay, so we know that it's going. When I see that the HTTP probe is getting errors, I know it's not doing anything for me. So I would rather just turn it off and then take the time to interact with the container myself.
Right.
See what's going on. So, right, 410 packages, about 1,200 vulnerabilities. And I'll look at, let's see how many of those are critical, and a bit of a, where am I? Oh no, I just stored that all the way out in the outside of the repo. Somebody that's better at Gripe than me might laugh at this, but I just pull F for critical on the report I outputted. So that's like 14, and they're all right column.
Yeah.
So 14 criticals, 1,177 overall. Anyway.
So what I find interesting about this is there's something similar that you see when you use the Python latest container that's built with Debian. I can see from the package versions there that this is a base image that's built on, that's using Debian 11. And again, this is one of the things I dig into in my 5 best security practices, because choosing like your the right starting point for your application can make all the difference to the security profile. So, for example, Ubuntu, SUSE, and specifically RHEL, they have SLAs and full-time security teams. So they have well-patched container images. The base images for those distributions have SLAs to mitigate all high and critical vulnerabilities. Whereas Debian is a community project and can't offer the same kind of commitment to security patching stuff, which is why you see what you've got here, which is packages with lots and lots of vulnerabilities. And also, interestingly, you see that won't fix in there. And this is because the Debian project has elected that they're not going to fix the vulnerabilities that exist in these packages in that release of Debian. It's fixed in an upcoming release, which is actually going to be out maybe May or June next year. So consequently, you're just stuck with these vulnerable things if your application requires them. Your only recourse is to rebase your container on a distro that doesn't carry those vulnerabilities by default. And this was one of the big ways I got my application. I packaged it or containerized it on Debian and Ubuntu and Distroless, which was also effectively a Debian derived distribution, and Alpine and a couple of others as well. But because Distroless is built on top of Debian 11, even though the container was way smaller, it was a multi-stage build, the container was smaller, it still had stacks of vulnerabilities inside it because it was built on top of a by default vulnerable Debian 11 base image. So yeah, I could see that it would be easy to build your Rust app, like start with Debian, start with Ubuntu, install the Rust sort of language dependencies to build your code inside that container, and then minimize that. You'll probably have a smaller container image as the base, and you'll throw out all of the dev tooling as part of the minification process, but you won't be carrying vulnerable libraries in that base container because you've used Ubuntu as opposed to Debian. If that will make sense.
Yep. Definitely. So again, killing the when I just terminated the slimming process here, it outputted a 10.6 megabyte container,
Right.
which, sounds great, but since the crawler failed, we shouldn't expect this container to work.
Right.
But I found that even taking that container and then running it in the foreground so you can see what might cause it to fail is helpful. So
Okay.
we can see those those logs I put in. Oh, right, it's not going to continue to. It'll open, but once I try to call to it, I suppose it'll tell me more. Not even trying to handle connection yet.
Yeah. Okay.
Yeah. Oh, panicked.
No such file or directory. So it looks like it may have removed the actual application. No, not the application.
So that's the yeah, because that unwrap is happening in the main.rs, so it's hitting that, and it's not finding such file directory. Yeah. So sometimes the process like this debugging strategy of slim it and then find out what thing to include based off what's making your crashing, what makes it crash works, and then other times you want to figure out how to fix the crawler. I don't know if we're gonna get to the bottom of this right now, but result unwrap in main. That's what does it say? Line 31.
Yeah.
File. Yeah.
So I'm guessing unwrap is sort of a feature in like the standard library, and maybe the Rust standard library is on the in the minimized image anymore.
Well, it looks like it knows the unwrap function, right? Because it's able to call it, and then it's the what line was it? 31. This file name, it seems like it's not able to find it. No.
Oh, this is your actual HTML files. So you need like an include of your an include path for your assets.
You know what? Let's try that. Let's see if we just fix the problem right here. Yeah, that would make sense. It is always nice when you manage to slim it without actually like probing it or monitoring it. Sometimes the startup and then like a single include path is enough. So let's back to Docker Slim builds, and I want to tag this.
Hello, Crosbow. Thank you very much for your helpful advice. Unwrap is for ignoring the errors. Yes, thank you. Yeah, we're just stepping through this to see what's going on here. What we're doing is we're using Docker Slim at the moment to take a container with a Rust app inside it and minify it or harden it, so make the container as small as possible. And we've removed the static assets that the app is a web server, and we've basically removed the pages that web server is intended to serve.
So this path should work, right? Because the Docker file is in app, so it's not going to no app. It's just,
so it's just
I just
assets.
need to do assets. Yeah. Let's see, build probe is off because we don't want it. We include the assets. Sure, we'll show logs.
It also, the probe may work now if you're keeping the assets Oh no, that
Probably
won't
not,
change
because,
anything.
yeah,
Actually, no, it won't.
yeah, because the temp container shouldn't have anything removed.
Yeah.
Oh, was there an error output right there, a warning or something? What are these? No such file. It doesn't like the Docker Slim artifacts files certs. Interesting. Let's see what the image outputted first before we dig into that. New one is. Well, that's interesting. It didn't give the tag I asked it to. That sometimes happens if it gets like an error in the container. It will just name it the default, which is original container name .slim. Anyway, let's see if we can run it. See if we get the same output as before. Main. Ooh, that's what we wanted to get.
There we go.
It's still 10.6 megabytes. That's good.
Yeah. Well, we've only included a couple of very short HTML files, so it shouldn't change the container size. There we go. That's right. That was your 404. Yep. That was your 404. Yeah.
Yeah, that looks good. Let's just. I mean, it should definitely work on browser. Looks like, yeah, I think you caught it. It was the assets it was missing.
So that's not bad. So we've gone from a 1.44 gigabyte container to a 10 megabyte container. I like those.
Right,
I like those numbers.
yeah, it looks pretty nice. Yeah, this will be. Well, I'm glad we spotted that, because now I'm going to be able to put out this the starter kit before the launch.
Nice. Well, there we go.
Yeah.
We got some value for ourselves.
Thanks for doing my job, Martin.
You're welcome. You're welcome.
Yeah.
I have my uses on occasion.
Yeah. I'm gonna stop sharing that. It looks like we did good investigations into all three.
Okay, so let me just flip back here. Yeah, that's great.
I could just.
So, for those of you that have joined later on, we started by looking at a 9 gigabyte container that has an AI/ML engine for doing the AI generation with DALL-E Mini, I think it is, isn't it? The crayon end.
The crayon one,
yeah. And then we took a look at the Mongo stack using Docker Compose and minimizing each of the discrete components, and also significantly reducing the attack surface in those containers by making them smaller. They didn't get much smaller, many of them. They were quite well constructed container images, but they had vulnerabilities in them nevertheless, and we were able to hoover a lot of that out, which was great. And then this one is the Rust container, has loads of dev tools in it by default, so when you use it as a base image and then strap your application to it, you end up with a 1.4 gigabyte container, and you've been able to reduce that down to 10 megabytes, which is pretty great. That should be pretty low on the vulnerability count as well, because all that will be left in there now is that Rust binary and a couple of HTML files, which is pretty cool. Well, thank you, Stephen, for coming on and sharing all of that with us. Now, we, as SlimDevOps, are going to be back again tomorrow at a similar time, about this time tomorrow, about an hour earlier than this. And it will be me and Pete, and we're going to be talking about the Slim.AI hackathon, which we launched a couple of days ago. And this is an extended hackathon that's running for about 5 weeks, I think, if my maths is right. And there are cash prizes for the winners. So if you've got an idea for a containerized project and you've got it burning a hole in your mind and you want to get on with it, now there's some additional motivation to actually work on it, because we have a panel of judges who will be looking at all of the entrants, and several of you will be up for winning some prize money as a result of your contributions. So if you head to Slim.AI, you'll find the details there, or just pop back tomorrow. Pete and I are going to go through everything about the hackathon and everything you need to know. And we've already got a few people that have started, so you don't want to wait too long, because there's already people who are working on their projects for this hackathon. Is there anything else you want to add before we put a bow on this, Stephen?
I'll see you all on Halloween, I guess.
Yes.
Next time you see me, I'll be in costume.
Yes, as will I. Apparently, I've been reliably informed today.
Yeah.
So, that's October the 31st. That one. So yeah, get subscribed for that. And what we're going to do, now, is we're going to head over to Corbin Crutchley's channel. He's one of the core devs for Astro, which Pete and I were playing around with a couple of weeks ago. Pete did his own personal blog using Astro, so I've totally put the wrong thing in the chat. Look at what I did there, silly boy. I was doing the whole raid thing and I've put my commands in back to front. So we'll try that again. We'll go raiding. So thank you all for coming, and hopefully we'll see you back here tomorrow. But we're now going to head over to Corbin's channel. Thanks very much, Stephen. See you soon.
Yep, thanks, Martin.
Bye for now.
Yep.